Welcome back, ladies and gentlemen. This is the second half of Chapter 3, Section 3 notes covering all of the Algebra 1 material over slope. Remember that we were talking here about coplanar lines. This video is going to cover the relationships between the slopes of parallel lines and perpendicular lines. So we have a pair of postulates here covering the slopes of parallel lines and the slopes of perpendicular lines. Now these are not things we're probably going to be using in proofs, so they don't have the most formal names. They are simply rules that we do not need to prove. So first up is for parallel lines. Two non-vertical lines have the same slope if and only if they are parallel. In other words, parallel lines will always have the same slope, equal slopes. For perpendicular lines, the rule is a little bit more complicated. It says that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now, this could also be viewed as those two slopes being negative reciprocals of each other. Okay? So in the example here, we have three lines, line L, line M, and line P. Line L has a slope of 4 over 1. Okay, again, we talked about how to do that in the last video. So we have to find 2 points, and we need to go up 4 and right 1. Okay, up 4, right 1. The rise over run is 4 over 1. 4 over 1 gives us a slope of 4. Line M also has a slope of 4. Again, we just locate two exact points. These two here would work. And again, up 4, right 1. What this tells us is that line L, since the slope of line L is equal to the slope of line M, L is parallel to M. Now then we have line P. Now line P, if we locate 2 points there, you'll notice it passes through the origin and it also passes through the point 4, -1. So to get from one point to the other, we need to go down 1 and right 4. Down 1 and right 4 would give us a slope of -1/4. So notice that is not the same as the other two lines, meaning they are not parallel. However, if we multiply the slope of line L by the slope of line P, which means 4 times -1/4, that is -1. What that tells us is that L is perpendicular to P. So in other words, all we need to do to figure out whether two lines are parallel is check to see if their slopes are equal. To check to see if two lines are perpendicular, we multiply their slopes together, and if that product, that answer, is -1, then those lines are perpendicular to each other. This could also be stated as those two lines have a slope that are negative reciprocals of each other. Now what that means is that one is positive, one is negative, and they are reciprocals, meaning one is a flipped fraction version of the other. So it would require both of those things. One would have to be positive, one would have to be negative, and they would have to be reciprocals. All right, so let's do some examples. Here we're supposed to determine whether lines A, B, and CD are parallel, perpendicular, or neither. Now A is located at the point 1, 1. So let's go ahead and graph that point. 1, 1 is located 1 unit right and 1 unit up from the origin. And B is at the point -1, -5, which is left 1 and down 5 from the origin. What we're going to do is we're going to use a straight edge to draw a straight line through those 2 points. All right, so let's see here. That would look something like this. All right, then we have our other line, which is line CD. Line CD passes through the points 3, 2, which is right 3 and up 2, and the point 6, 1, which is right 6 and up 1. So that line would look like this. All right. Now, the drawing itself is not enough information to declare whether these lines are parallel or perpendicular. Let me say that again. The graph itself is not enough information to declare that these lines are parallel or perpendicular. You have to do more. So what we're going to do is we're going to use our slope formula. A is going to be our x1 and our y1. B is going to be our x2 and our y2. And we are going to find the slope of line AB using the slope formula, y2 minus y1 over x2 minus x1. Now we did this a lot in Algebra 1, so this should be review. All we're going to do is plug in those points. That would be negative 5 minus 1 over negative 1 minus 1, which would be negative 6 over negative 2, or a slope of 3. We will then repeat those steps with C and D to find the slope of CD. So we label our 2 points C and D as x1, y1 and x2, y2. And again, we're going to plug those in to the slope formula, which again is from our first video, something that should be memorized by everyone. So y2 minus y1 would be 1 minus 2. x2 minus x1 would be 6 minus 3. And again, that's just me pulling the x and the y coordinates from point C and point D. Simplify that, we're looking at negative 1 over 3. That fraction cannot be reduced. Now, those are not equal, okay? The slope of AB does not equal the slope of CD, which means AB is not parallel to CD. Okay, they're not parallel. They're not the same. So that is not the correct answer. Now you're going, duh. I mean, look at the picture. They're clearly not parallel. Well, in the picture, it does appear that they are perpendicular. So again, to check perpendicular, what we do is we multiply the slope of AB times the slope of CD. That would be 3 times negative 1/3. That is equal to negative 1. If they multiply to negative 1, that means that those slopes are negative reciprocals, and that means that line AB is perpendicular to line CD. So our answer would be line AB is perpendicular to line CD. Okay, let's do another one. That's the amount of work, by the way, that we would need to show in order to properly justify our response. So on to the next problem. Okay, same exact problem type. Now you will notice the graph itself is going to be a little bit problematic here because A is more than 10, which means we need to change the scale on our graph. Okay, we need to change the scale. We're going to need to go by 2 on both the x and the y. And what I mean by that is that each line is 2 units instead of 1. So each line, they'll go from 0 to 20 by 2s, etc. Okay? So, we are again going to go in here and we're going to graph line AB just real quickly. 14, 13, 2 would be 2, 4, 6, 8, 10, 12, 14. 13 would be right there. And the point negative 11, 0 would be right there. So our first line would pass through those 2 points. And again, a ruler would be very useful in this situation. They're located at the front of the room. If you need one, you should grab one. Okay, then we have line CD, which I'm going to graph in red. C is located at negative 3, 7, which would be right in the middle of this box right here. And negative 4, negative 5, which would be halfway between the second and third line right there. Okay, so that line would pass through those 2 points. Again, use your straight edge, get a nice straight line. Now looking at these two lines, it definitely would appear that the answer here is going to be neither. These lines are definitely not parallel, and they do not appear to be perpendicular either. However, we still have to do the work to complete this. So again, we take our A and our B, we label them x1, y1, and x2, y2, and we find the slope. y2 minus y1 over x2 minus x1. That is 0 minus 13 over negative 11 minus 14. That would be negative 13 over negative 25. We can't do anything to that except a negative divided by a negative would be a positive. We will then repeat those steps for C and D, x1, y1, x2, y2. So our slope for those 2 points, which again is CD, I guess I should have labeled the other one as AB, so let me do that now. Might as well label our graph while we're at it. This is point A, this is point B, this is point C, and this is point D. That's a terrible situation here. Let's get that fixed. There we go. All right, so y2 minus y1 using C and D, x2 minus x1 would be negative 5 minus 7 over negative 4 minus negative 3. That would be negative 12 over negative 1, which would be positive 12. Now, once we have those slopes, a simple comparison of slopes for AB and CD would show us that they are definitely not equal. Clearly, 13 over 25 is not equal to 12. Now what that tells me is that AB is not parallel to CD. Okay, then I would turn around and say, okay, well what if I multiply those slopes together? Well, if I multiply the slope of AB times the slope of CD, I am doing 13 over 25 times 12. That is definitely not equal to negative 1 because both of those numbers are positive. In order for there to be any chance of them being perpendicular, one would have to be positive and one would have to be negative. That would be, let's see here, 156 divided by 25, which is not equal to negative 1, which means that line AB is not parallel to CD. So our answer here would be that these lines are neither parallel nor perpendicular. All right, there's one more of these. I would like you to try it on your own. Now I want you to notice that the graph itself does not actually provide you with the support needed for the problem. So in theory, you don't need to graph them. The reason I'm having you graph them here in your notes is because the graph does have value. It allows you to quickly check whether your answer is correct. So when you try this third example, please graph them before you start. That will tell you what you should expect when you do your slope formulas. All right, so pause the video, try the last example, and then resume the video and see how you did. Okay, so we're going to again graph line AB. A is located at 3, 6. That would be right here. B is located at negative 9, 2, right there. Okay, C and D. Actually, let's get that line graph first. We're going to graph a line through those 2 points with our straight edge tool. And yes, I do know that my screen shifts, but it always shifts back. So there we go. Okay. C is located at the point 5, 4. And D is located at the point 2, 3. So that line would be right here. Now looking at those lines, they certainly appear to be parallel. But again, we cannot be sure of that. We have to actually check the graph. Okay? So what we do is we do slope formula. A would be x1, y1, B would be x2, y2, for me to find the slope of AB. So I'm going to do y2 minus y1 over x2 minus x1, like we practiced in the first video. So 2 minus 6 over negative 9 minus 3 would be negative 4 over negative 12, which would reduce to 1/3. We would then repeat those steps for C and D. So again, for C and D, we're going to label C as x1, y1 and D as x2, y2. And we're going to plug them into the slope formula, y2 minus y1 over x2 minus x1. That would be 3 minus 4 over 2 minus 5, which would be negative 1 over negative 3. Only thing we can do to that is that a negative divided by a negative is a positive. Now we should immediately notice that slope of line AB is equal to the slope of line CD. What that means is that line AB is parallel to line CD. This confirms what we already saw on the graph. All right, folks, that should do it for section 3 of chapter 3 over slope. Yes, it does. Thank you very much for your time and attention.